Hello everyone. Today we are going to discuss our first chapter, motion and time. Okay. So motion is a common experience in our daily life, right? We observe birds flying in air, buses, autos, cars move on roads, trains moves on tracks. Many other objects around us in motion. So not only the other object and vehicles, birds and everything, we also experience motion while walking, running, playing, riding bicycle and etc, right? Yes or no? So motion is nothing but movement. As we said now, even the vehicles, buses, birds, what they are doing, they are moving from one place to other place. So motion is nothing but movement, right? Yes or no? So suppose let us consider you are going to one place. So when we sit inside a moving bus or train, we observe that the objects like trees, buildings, display boards appear to move backward direction, right? As we are going, suppose you are traveling like this, okay, in this direction. Suppose your bus is going in this direction. So how you feel the trees which are besides the road, this side and this side poles and everything will you are going in this direction, right? We feel like these poles and buildings and everything is moving in backward direction. We feel like this feeling, right? We'll get this feeling while going, while traveling, right? Are these trees, buildings really in motion, or are they at rest? To understand this, we should understand the meaning of motion and rest. Okay, so if you know exact meaning of motion and rest, meaning of motion and rest, you can say whether the bus is moving in motion or rest, or these objects like poles, trees and everything is in motion or rest. Okay, so so what is motion actually? So suppose I'm assuming I'm taking a tree. Okay, so here this is a road. Okay, tree is there. Suppose a car is moving like this. Let us consider this is a car. It is coming and moving in this direction. Okay, so one more diagram I'm considering. Again the same tree and the same road. Okay, now the car is at this position. Same car, don't think it is the other car, same car. Diagram is little bit different. Okay, so see, observe tree position. So with respect to tree, where is car? Here. Okay, in this position car is there. So next in this is consider first diagram. In second diagram what happens, this car is here. Okay, here. So from these two diagrams what you can understand, with this car is moving, with this car is in motion, right? Yes or no? So if you sit in this car, how you feel, this tree also in a motion, right? Your this tree also in motion, because it, while you are moving in this direction, forward direction, this trees poles will move in backward direction. So actually who are in motion and who are in rest? Okay, so let us consider this car. Okay, so with respect to this tree, this car is moving, right? And also with respect to the surroundings, this place of the car initially here and finally it came and it is here, means the position of the car is changed with respect to time, right? Yes or no? So initially here, the car is here and finally the car is here, means car is moving. And also observe the position of the tree. Initially the tree is here itself, again the final position also in the same position with respect to the surroundings. So To decide whether the object is in motion or rest, you have to compare the position of this tree or this car or anything, any object, with respect to the surroundings. If the position of the object is changing with the surroundings in a particular interval of time, then the object is said to be in motion. Okay, so what is motion? An object said to be in motion if it changes if an object is said to be in motion if it changes its position with respect to, okay, in short form I'll write WRT, but you don't write in short forms, okay, with respect to its surroundings. In a given time. Okay, so what is motion? An object is said to be in motion if it changes its position with respect to its surroundings in a given time. Okay, in a given particular interval of time, the object is changing its position with respect to surroundings, then it is said to be in motion. So what is rest? An object is said to be in rest if there is no change in its position with respect to its surroundings. In a given time. Okay, then it is said to be in rest. Okay, so what is motion? An object is said to be in motion if it changes its position with respect to its surroundings. Okay, with respect to surroundings, if we compare with the surroundings, the position of the object is changing in a given time, then it is said to be in motion. Okay, if it is not changing its position, then it is said to be in rest. Okay, so let us take some examples. Okay, so a man is traveling in a boat. Okay, let us consider. So a man is traveling in this boat. Okay, traveling in this boat. So observe his motion. Okay, the man is in the boat, he is moving with respect to bank river, right? Okay, yes or no? So he is changing its position, his position, right, with respect to bank river. Suppose bank river is here. Okay, this is, let us say, bank. So then he moved a little bit, right? So means with respect to the bank of river, he is in motion, right? Yes or no? But with respect to boat, he is in motion or rest? In rest. Okay, suppose you are riding a bicycle. Okay, you are riding a bicycle. Okay, let us consider this is bicycle. So I'm not good at drawing. Let us consider. So this is bicycle. So you are sitting on this bicycle and you are riding. So with respect to the surroundings, this bicycle in motion, right? Yes or no? Because it's changing its position. Okay, so What about you? You are sitting on the bicycle, right? You are in motion with respect to the surroundings, but you are not in a motion with respect to bicycle. You are at rest. Okay, yes or no? So this is about a roughly motion. What is motion and what is rest? How to define a, how to tell a object is in motion or rest? You understood now, right? So what is motion, what is not motion, which objects in motion and which objects is at rest, you can easily define now, right? Yes or no? So in motion, two types are there. Okay, what are they? Uniform motion, uniform and non uniform motion. So what is uniform motion? So you know meaning of uniform, right? Uni means a common, form means a, suppose uniform means your school dress also, right? You can all students wear same color of a uniform, means uniform means equal in equal, right? Yes or no? So what is uniform motion? If a body covers equal distances in equal intervals of time, then it is said to be in uniform motion. Suppose a car is there, it is moving. Okay, a car is there, it is moving. Suppose it took 5 hours to travel from A to B. A to B it is took to travel. Let us take 2 hours. Okay, 2 hours. So this distance is 10 kilometers, 5 kilometers, and 5 kilometers. So in 1 hour it is covered. In first hour it is covered 5 kilometers. Next second hour it is covered again 5 kilometers. So in total from A to B it is traveled equal distances in equal intervals of time, right? Yes or no? So then these objects means here, suppose you are traveling in a car, that car is moving from half distance, that is 5 kilometers in 1 hour, and again one more or 5 kilometers, means equal time 1 hour. In 1 hour 5 kilometers, in 1 hour 5 kilometers, means you are traveling in equal intervals of time, equal distance. Then your car is said to be in uniform motion. Okay, if a body covers equal distances, seen, equal intervals of time, it is said to be in uniform motion. Okay, next, non-uniform motion. If an object or if a body covers unequal distance in equal intervals of time, then it is said to be in non-uniform motion. Okay, so you understood the meaning of uniform and non-uniform motion, right? Yes or no? So let us see, I'll explain. Let us see. Same A to B, you are traveling in a car. This time in first 1 hour you are covering 4 kilometers. Let us consider, okay, you are covering only 4 kilometers in 1 hour. Okay, in next 1 hour you are covering 6 kilometers. Here what happens, in equal intervals of time, but you are covering unequal distances, right? Yes or no? So then in the second case your car is said to be in non-uniform motion. Okay, now you understood what is motion and time in this lesson, what is motion and what is rest, how you can define a object is in rest or motion, and also what is uniform and what is non-uniform motion. So you can see so many objects like in a clock, seconds hand, minutes hand, and hours hand. These are said to be in non-uniform or uniform motion. In a uniform motion, okay, in 1 hour, hours clock is traveling how many degrees, you measure the distance in degrees with respect to time. You observe, you can say that the clock is the minutes and seconds and hours and or in uniform motion. Okay, so non-uniform motion examples you can consider a vehicles and also a bicycle. You are traveling in a bicycle in a non uniform motion, means equal intervals of time. If you change your speed you can cover unequal amounts of distance. Okay, so is it clear now? So next, suppose I'm asking you a question. You can see fans in your houses, right? Ceiling fans. So how they are rotating? What type of rotation is this? You just think of it. And tomorrow we'll discuss what are the how many types of motions are there, like oscillatory motion, translatory, and also rotatory motion. You will learn in detail. Okay, that's all for this class. Thank you.